morning, students. So today we are almost at the end of this periodic classification. So we don't know whether it finished today or not. So let's try. In the last class we have discussed some of the important properties and definitions. So today we are going to discuss the trend in the physical properties, means properties of the trend. Properties are nothing but some of the properties are having the similarity. That property varies from one end to the another end, from upper to the lower. So how it varies, that will be discussed here. So I hope you are very much familiar that in the whole periodic table, the properties are similar down the group. So in the modern periodic table, you can see the properties of the elements are appears to be similar only down the group. One thing. In the last class I discussed you, hydrogen is placed in the 18th group instead of second group. Why? Because it is having completely filled electronic configuration, or the electrons are completely filled in the first shell. For that reason, it obeys the property of noble gas. Hence, it is placed in the 18th group instead of second group. So same thing. It is also asked one more question. The F block elements are kept separately in the periodic table. Why? So I hope you remember the S block is at the left, P is at the right side, T is at the middle, and F is nothing but it is lanthanide. So no doubt, lanthanide and lactanide, these are the elements of 6th and 7th period elements only. Why they have kept separately? So in the high school we have learned that the reason is because due to the space, large space is required to place here. For that reason, to reduce the space, we have kept the F block elements below the modern periodic table. This is what you learned in the high school. But here we are going to give the separate meaning for that. That is, in the whole periodic table, the elements are appear the similar properties only down the group, except in the F block elements. Can you say all the S, B and P? So these are all are having the similar properties down the group. Only the F block elements are having the properties similar across the period. They are having the similar properties. For that reason, they have kept in the below the periodic table. Are you getting? If they ask for the reason, give the reason why the F block elements are kept separately or down, means because only F block elements are having the similarity, means properties are similar across the period. For that reason, they have placed it below, and remaining all the elements are having the properties similar only down the group. Do you understand this one? These are important for give reason. So one is F block element, another one is helium. Helium is kept in the 18th group. So let's begin the last chapter, that is last concept, periodic trends in properties of element. Means how the properties of the elements are varies. So look here, I hope this is not the new thing. This is not the latest or very unknown thing for you people, because you are already studied this in high school. So, but the definition and the headings are different, but the concept is almost the same. Look here, the first one, atomic radius. If they ask you atomic radius, what is atomic radius or what is atomic size, everything is same. What is atomic radius, what is atomic size? Sometimes it will be asked ionic radius also. Ionic radius or ionic size, everything is same. Ions may be positive ions or negative ions. Look here. Here, atomic radius is nothing but this is the atom. So to say the size, it may be a size or it may be radius. We are representing the size of the atom only on the basis of radius. For that reason, if they ask for the size or radius, everything is same. So the size or the atomic radius is nothing but it is the difference between the center of nucleus and outermost electrons. Center of nucleus and outermost electrons. This difference is called as atomic radius or atomic size, ionic radius or ionic size. If they may ask anything, but the definition remains same. Atomic size is nothing but it is the difference between center of nucleus and outermost electrons will be present in first shell, second shell, third shell. It doesn't matter where that last electrons is present in the outermost shell. That difference is called as atomic radius. Are you getting this one? So here the definition is not much important. Rather than that one is how this atomic size or ionic radius varies in the period wise and group wise. This is what the important. So look here, atomic size in the periodic table, keep it a clear view. So as I move down the group, atomic size is how it is changing, whether increasing or decreasing. It is decreasing. Can you see here? Atomic size is decreasing. Down the group, I am showing the below, means this is called as group. Below the group wise atomic size or atomic radius or ionic size, everything. So it is increasing down the group. Why it is increases means, look here, the first period, this is period wise, the first period is having only one shell. The second period is having two shells, means one will be present at the inner and second shell is there. In the third period, it is having the electrons are filling in the third shell, means initially one shell is filled and again second shell is also filled and electrons are filling in the third shell. So as I am below the second, means first is called as first period, second period, third period, fourth period, but we are not calling this as a period because we are looking only about the down. For that reason we are calling that as a group. As we move down the group, there is an addition of new shell takes place. There is an addition of new shell takes place. For that reason, atomic size increases down the group. Are you getting my point? I will say once again repeat here. Just observe here. I am saying first one is across the down the group. What will be the variation of atomic radius, atomic size, ionic radius or ionic size? Everything size of the radius. So here down the group, what happens? The atomic size increases. Why is it? Why? They will ask you the question. So sometimes they will ask you how the atomic size varies down the group. If they ask means you can explain atomic size increases down the group. Sometimes they will give you the statement and they will ask you the reason. Atomic size increases down the group. Give reason or why. So for that question, the atomic size increases down the group because as we move down the group, there is an addition of new shell takes place. For that reason, there is an increase in the size of atom. Are you getting? This is only one shell is present in the first, and next as we move down, there is another shell. It is initially K shell, and then shell is added. Next M shell will come, and next M shell will come. As the number of shells, new shells are adding as we move down the group. For that reason, the atomic size is increasing. Means distance between center of nucleus and outermost shell, it is increasing. For that reason, atomic size or ionic size, they are increasing down the group. Are you getting my point? This is down the group. Similarly, what will happen to the period? Look here, how the properties varies down the group. That will be reversed in the period. So it means that atomic size increases down the group. It means it has to be decreased across the period. Keep in your mind. Can you see here? The atomic sizes are decreasing across the period. So why it is decreasing means, just look here. I would like to draw one more period here. So here, just take this example. I am talking regarding all the period, not only one period. So if I said that down the group means every group atomic size increases, every period atomic size decreases. Why? Because look here, if I look at any one of the period, in that period there is no increase or decrease in the shells. Shell remains same. If the first period means only one shell will be there. In the second period means only second shell the electrons are filling. In the third period, the electrons are going to fill only in the third period, means third shell. First period is first shell, second period is second shell, and third period the electrons are filling in third shell. So it means that if you look at a particular period, there is a number of electrons are increasing in a particular shell. Means number of electrons. Here it is having 1 electron, this is having 2 electron, this is having 3 electron, this is having 4 electron, and this one is having 5 electron, and this is having 6 electron. I understand the number of shell do not undergo any changes because shell remains same in the period. But what happens is the number of electrons are increasing in the particular shell. So it means what? In the center it is containing the nucleus and protons are there. So as the number of electrons increases, simultaneously protons also increases. Why? Because the number of electrons should be equal to the number of protons. How many electrons are there? The same number of protons will always present. Keep in your mind. So here, as I said, as the number of electrons are increasing across the period, if the electrons are increasing across the period, it means in the center nucleus containing proton, that is also increases. So it means that proton increases means positive charge increases in the nucleus at the center, and in the outermost shell, as the number of electrons increases in the outermost shell, electrons being a negative charge and the center nucleus being a positive charge, it both are undergo the attraction. Positive charge at the nucleus and negative charge at the electrons, they are undergo the attraction. For that reason, atomic size is compresses. Are you getting my point? There is no change in the shell. There is no addition of or decrease in the shell. Shell remains same. But as the number of electrons are increases in a particular shell, as the number of electrons increases, the positively charged nucleus is there. The positive charge nucleus and the number of electrons both are undergo the attraction. For that reason, atomic size is compresses as we move across the period. Are you getting my point? So across the period, atomic size decreases due to increase in the number of electrons in a particular shell. In a particular shell, number of electrons increasing, electron being a negative charge, and middle it's containing the proton positive charge, therefore atomic size decreases. Are you getting this one? So this is the reason why the across the period atomic size decreases and why the down the road atomic size increases. So these are the reason for both atomic radius, atomic size, ionic radius and ionic size. Are you getting this one? This is, I think you are heard this expression in the high school. If not, means go through once again and understand this one. So this explanation I will send you in the notes. Don't worry, because this is important. So coming to the next one, ionization enthalpy. Ionization enthalpy. So I hope you know what is ions. Ions are nothing but which are containing positively charged cation and negatively charged anions. So here ionization enthalpy is nothing but what? Enthalpy is nothing but energy. Energy is called as enthalpy. So think that this is the atomic size. One more thing I would like to tell you: shielding. Shielding, or it is also called as screening effect. Screening effect. What is this screening or shielding? Shielding is nothing but, just now I said in the atomic size, center is containing the proton, that is nucleus. As the number of electrons are increases in the outermost shell, there is an attraction between outermost electrons and center of nucleus. For that reason, atomic size decreases. One more thing. Here, as the number of electrons increases, no doubt, electrons being a negative charge, each of the electron being a negative charge, they should undergo repulsion between each other. Keep in your mind, the electrons being the same charge, negative, they should undergo the repulsion. And there is an attraction between only the outermost electrons and center of nucleus. It means, so they will maintain some distance as we all maintaining in a corona social distance. Like that, the electrons also maintaining some distance just because they are having the like charges. Means they are having the same charges. For that reason, they are under some distance. Means repulsion will be there. So as it is maintaining some apart distance, that distance is called as shielding or screening. Shielding effect is nothing but as the atomic size increases or decreases along with some distance of repulsion of minimum repulsion of electron, that is called as shielding effect. Shielding is nothing but the distance or compression or a distance. So how that electrons are maintaining the aparting, means they are maintaining some distance due to that repulsion between the same charge, that is called as shielding. So no doubt in this first case, in some chemical bonding you may go through that concept, but in the second QC also we are not carrying that one, but somewhere in that competitive exam it will be here for that reason shielding should remember. So coming to the ionization enthalpy, so I say we are having the number of electrons in the inner shell, but we never bothered about the inner shell. So in the outermost shell, as the number of electrons increases, that electron, it may have 1, it may have 2, it may have 3, 4, 5, 6, any of the number. But we can remove the electrons from the outermost shell, keep in your mind. So you think that this is the nucleus and it is having K shell, L shell and M shell. So if it is having K, L, M, N, means after filling K, L will fill, after filling L, M will fill, after filling, complete filling of M, N will fill. Is it clear for you? Means until the inner shell completes, there is no filling of electrons takes place in the next shell. I hope you know this one. So after filling K, L will start. After complete filling of L, M, and after complete filling of N, after completely filling of K, L, M, the electrons will be filled in N shell. Is it clear? So now we are at N shell. Are you getting? Now we are at N shell. It means that the inner shells are completely filled. We never bother about the completely filled shells, means inner shell. We never bother. What is, how many electrons are there? Which shell it is filled, in which shell we are. We never bother. We are not going to touch. We never going to calculate the electrons and how they are having. Not even in the PUC, never in higher education also. Even though if you for BSc and MSc, we are not bothered about the inner shell or inner electrons. We are going to worry only about the electrons present in the outermost shell. Keep in your mind, that is the most important we are discussing throughout our education. Here, ionization enthalpy is nothing but we can remove the electron which is present in the outermost shell, not inner shell. It is not possible to touch also. So here the number of electron which is present in the outermost shell, not only here. If it is having only one shell, we can remove that shell. Electron present in that shell. If it is having only two shells, think that it is K and this is L. So here L is nothing but outermost shell. So we can remove the electrons of outermost shell. So how much energy we need to remove the outermost electron? That is called as ionization enthalpy. Enthalpy is nothing but energy. What is ionization enthalpy? The amount of energy required to remove the outermost electron. Means that if it is having second shell, we can remove the electrons of second shell. How much energy required to remove only one electron, that is called as ionization enthalpy. To remove the first electron, that is called as first ionization enthalpy. To remove the second electrons, that is called as second ionization enthalpy. You are going to study this in detail in the second PUC. So it is only the introduction. So what is ionization enthalpy? Means amount of energy required to remove the outermost electron. Is called as ionization enthalpy. Are you getting this point? The definition is important here. And how the ionization enthalpy varies. Look here, same thing. The atomic size increases down the road. Can you see here? Ionization enthalpy is nothing but this is center of nucleus being a positive charge and it is having electron because atomic size is very small. Here atomic size is larger one. It means the distance between center of nucleus and outermost electron is very much apart. For that reason, we are saying the atomic size is increasing. So, just to think, ionization enthalpy means energy required to remove the outermost electron. Here, electron is very near to the nucleus, means positive charge and negative charge, they are very near. So, it means they are strongly bonded to each other. And here, the proton and outermost electrons are little bit having some distance, greater distance is there. So where we need the greater energy, whether to remove this electron or to remove this electron? Come on, answer. At least you can answer yourself now. Here electron is very near to the proton. Here electron is little bit far away to the nucleus, so that it is having greater attraction between center of nucleus and outermost electron. Can you see here the distance is short, means it is strongly bonded. So it means to remove this electron we need the greater ionization enthalpy. Ionization enthalpy required is greater for upper elements. As we move down the group, ionization enthalpy, what happens, it is decreases. Are you getting my point? How it is means, as the atomic size increases, we can remove the electrons by lesser energy because it is having greater distance between the center of nucleus and outermost electron, so that we need less energy to remove this outermost electron rather than this one. For that reason, the ionization enthalpy decreases down the group. And across the period, what happens here? Same thing. Down the group, ionization enthalpy decreases just because the distance is far away. Here, across the period, the ionization enthalpy increases. Why? Because as the number of electrons are increases, atomic size is decreasing. So it means that to remove the electron which is near to the nucleus, it need greater energy. For that reason, the ionization enthalpy increases across the period and decreases down the group. Are you getting this point? So I hope you can't feel it is difficult. This is very simple thing. The definition is important, and for 2 months or at least for 1 month you may get the definition. For 2 months you may get explain the trend or give the variation of ionization enthalpy across the period and down the group. So you should be capable to explain this one. And these two are very simple because we have learned in the high school. Electron gain enthalpy. Electron gain enthalpy means energy required to receive the electron. That is called as electron gain enthalpy. The very simple, I will explain you in a different way. Electron gain. So just tell me that the element which receives electron, that is called as electron gain. Which element can receive the electron, whether metal or non-metal? So here metal are going to lose the electron, where non-metals are going to receive the electron. That receiving electron is itself is called as gaining the electron. Gain is nothing but receives the electron. The element which receives the electron, that is called as electron gain enthalpy. Electron gain enthalpy, how it is? Electron gain enthalpy is nothing but we are going to say about the non-metal. Electron gain enthalpy, how it varies. Similarly, can you see here electronegativity? Electronegativity. So which element are undergo negatively charged elements, whether metals or non-metal? It should be the non-metal, because non-metals are having the negative charge, whereas metals are having the positive charge. Metals are called as electropositive and non-metals are called as electronegative. So it means here we are going to discuss together it is about the non-metal only. Indirectly we are explaining about the non-metal, but you are not supposed to use the word as a non-metal. You have to use the word as electron gain enthalpy varies across the period down the group. You have to say that way only. Don't use the word non-metal. Here also electronegativity, how it varies across the period and down the group, you have to say. But in your mind you should keep that these two terms are going to describe indirectly about the non-metals. Are you getting my point? So let's begin. In the periodic table, where can you able to observe the metal and non-metal? This is S, this is P, this is P. I want to draw that neatly, but somehow you can able to understand that one. Look here, the non-metals. First of all, I would like to say you the metals are at the left side and non-metals are at the right side. I hope you know this one. This is metal and this is non-metal. So here, metallic character decreases as we move down the group, and as we move across the period the metallic character decreases. Why? Because metals are greater here. These are the non-metal. If I talk about the metallic means it has to be decreased. If I talk about the non-metal means non-metallic characters are increasing here. Non-metal characters are increasing. Non-metal characters are increasing in the sense what? Electron gain enthalpy is increases across the period. Keep in your mind. So if I talk about the non-metal means you have to use the word electron gain enthalpy increases across the period. It means that it has to be decreased down the group. Why? Because as we move down the group, atomic size increases. As we move atomic size increases, we can remove the electrons easily. If we remove the electrons easily, means it can lose the electron. The substance or the element which can lose the electron, it should have the metallic character. Keep in your mind, everything is correlated, interrelated to each other. So as we move down the group, atomic size is larger. It means we can remove the electron. If we remove the electron means it carries the positive charge. The element, the species which carry the positive charge, that is none other than metal. For that reason, so as we move down the group, metallic character increases. It means non-metallic character decreases. Are you getting my point? So it means that both together I am telling electron gain enthalpy and electronegativity is across the period it is increases because non-metals are at the right side. It's increasing non-metal. For that reason, across the period, electron gain enthalpy increases. Similarly, electronegativity is also increases across the period. Are you getting the point? And down the group, as we move down the group, electron gain enthalpy decreases. Or in other words, electronegativity is also decreases as we move down the group. Are you getting this one? This is about the electronegativity and electron gain enthalpy. These both are means what? Non-metals. So this is about the properties. The properties strength, how they are varies in the periodic table. So coming to the one more important point, I hope anomalous property, they are not actually, it's slightly different compared to the next chapter, but I will explain you. What is anomalous property? Anomalous property is nothing but, I will tell you the definition. I mean, it's not definition, it is some variation. Just have a look at that one. So coming to the very last concept, this is not much important. Why? Because due to this corona, some of the portions are reduced and most of the portions are retained actually. So based on that, even though it is reduced, I am explaining why. Because it will help you not in the examination point, somewhere in competitive exams, not for the text, but this term will help you to understand another concept. For that reason, I am explaining. So here, whatever we have discussed, these are the physical properties, means changing in the size. Next one is periodicity trend in the chemical properties. Chemical property, how these chemical properties are varies. Keep in your mind, I said the properties are similar down the group, not across the period. For that reason, the chemical properties are similar down the group. You have to say the word down the group, only the chemical properties are remain same. How? Because as I look at one of the group, if I said group 1 is having a similar property, on what basis I am saying means here every first group is having only one electrons in the outermost shell. Keep in your mind, the first group is having the only one electrons in the outermost shell. For that reason, every element in the first group is going to donate that electron. That's why it's carrying the charge +1. Similarly, the second group elements are having the only two electrons in the outermost shell, means they are having the same property. The properties of the elements are same. Why? Because they are having the same number of electrons in the outermost shell. For that reason, we have kept in the same group. Here, it is having only 2 electrons in the outermost shell. That is going to donated by the 2 electrons by second group. For that reason, every element of group 2 is having the charge +2. Are you getting my point? So it means that this is the reason we can say the chemical properties of the elements are seems to be a similar only down the group. Group wise they are having the same property. One thing. So and what is the valency valency is nothing but number of electrons present in the outermost shell. Number of electrons present in the outermost shell is called as valency. Can you see here the group, each of the group is having the same number of electrons in the outermost shell. Means valency of the first group is 2, valency of the second group is 2, and similarly valency of 13th group is 3. So it means that the number of electrons in the outermost shell, they are having same number. For that reason, they are having the valency as the elements, those are having the same valency, they are going to exhibit the same property. It means that the group wise they are having the same property. One thing. Another one is oxidation number. Oxidation, not number, oxidation state we are going to class, because oxidation number it seems to be another different meaning. That's why oxidation state. Oxidation state is nothing but what? So I say you, the first group elements are going to lose that one electron. For that reason, it is going to carry plus one charge. For example, sodium, potassium, lithium, they are going to lose one electron. For that reason, it is having the charge plus. If I written only plus means it's understood it is plus one. Similarly, magnesium, barium, these are having plus 2. Plus 2. So what is the charge magnesium is having? Plus 2. It means it is lost 2 electron. It means it is donated 2 electron. How much electron it donated? That is called as oxidation state. Oxidation state is nothing but the number of electron lost or number of electron gained. All the halogen in 17 group elements are having the charge fluorine, chlorine, bromine and iodine. These are going to have the charge minus 1. It means all the 17 group elements, these are going to receive 1 electron. It means that it needs 1 electron to make the outermost electron exactly 8. For that reason, these are 17 group elements are having the oxidation state is minus 1. Minus 1. Similarly, 16 group element, that is oxygen, sulfur, these are having the charge minus 2. Means these are going to receive only 2 electron. 2 electron. So that number of electron received or number of electrons are lost, that is called as oxidation state. That is called as oxidation state. So here the elements which are having the same oxidation state, they are going to undergo same chemical properties. The same thing what I explained. The group wise the properties are similar. The elements which are having the same oxidation state, they undergo the same chemical properties. Is it clear? It means that Mg and Bi, they are having the same oxidation state. It means they are belonging to the same group, for that reason they are having the same chemical properties. Similarly, the 17 group elements, they are having the same oxidation state. Hence, they are going to undergo the same chemical property. What is the chemical property? Chemical properties are nothing but what? Whenever hydrogen combines with the chlorine, hydrogen carry plus 1, chlorine carry minus 1, together it is going to form HCl. HCl. So Cl comes here, means this group elements, whenever instead of chlorine, if fluorine reacts or bromine reacts or iodine reacts, these elements are going to form the same formula. H. Instead of chlorine, I can take fluorine, that is HF. If I take bromine means HBr. If I take hydrogen, HF. Can you see here the formula remains same? Are you getting the same thing? So whenever the oxygen reacts with the first group, Na is carried plus 1, oxygen carry minus 2. So 2 comes here, Na2. Similarly, the oxygen when reacts with the other compound, potassium, means it will carry K2O. If it reacts with lithium, we are like 2O. Can you see here? It means that these are having the same kind of the property. Same kind of the property. Means properties of the elements remains same. That is chemical properties are remain same group wise. That can be expressed on the terms, that is oxidation state and valency. Are you getting my point? One more thing is, what is diagonal relationship? It is not much important, but it will be asked. Diagonal relationship is nothing but what? Look here, in the modern periodic table, it is having 7 period, 18 groups are there. I will try to make it clear for you people. That's why here in the second period lithium and beryllium is there. In the second period lithium and beryllium is there. So similarly, just below this one, in the diagonal way means you just look at like this. Lithium, beryllium. Beryllium property is seems to be similar to the aluminum. Can you see here? Lithium is second group. Second group is lithium, beryllium, and third group is sodium, magnesium, and aluminum. Just you go through the diagonally. Mean just you move in this way. So here below the beryllium, magnesium is there, isn't it? So next of magnesium is aluminum is there. Means beryllium, Be, and aluminum, they are having the similar properties. Similarly, lithium is having the similar properties to the magnesium. Diagonally means just cross. Just you look at in this way. Below the lithium, sodium is there. Next one is magnesium. Means lithium is having the similar properties to the magnesium, and Be, beryllium, is having the similar properties to the sodium. Means the properties of the element of second period and third period, they are similar properties across in the diagonal shape. Diagonal, not one below the another. They are having the similar atomic size. For that reason, this relation is called as diagonal relationship. Diagonal relationship is matlab. It means that the elements are having the same properties of second period and third period in a diagonal shape. For that reason, it is called as diagonal relationship. Diagonal relationship appears only between the second period and third period in this way, diagonal shape. Are you getting? So by this, I would like to conclude the chapter of periodic classification. If you are having any doubts regarding this, you can feel free to ask me, so that if your doubts, I will clear it by in another additional video. So otherwise, if you are having any doubt, just you call me. I will clear your every doubts. Don't wait for a good time to ask the doubt, because at what time you will be having them within that day, on that day only. So it's better to call in the college time before 11:30 to 11:30 if you call means, or 1:30 p.m. if you call means. I will be free, so that I can explain you in detail with a good mood. Otherwise, I will be a little bit busy. That's all. Okay, we will meet in the tomorrow. So until, feel free to ask your doubts and make the notes of this. Those who will make and send these notes, only for them I will, if I explain something notes, if I am sending means, only for them I am going to send the notes, because most of you are not sending the notes. I will check it out. So after finishing this chapter, you make a notes and make it in a PDF and send me. Only for them, if I send any important question means, only for them I am going to send the important questions. Okay, have a nice day. Bye.